On January 14, 2022, residents of Anchorage, Alaska heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega-tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research model showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen Volcano, Mega-Tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega-tsunami. The Vajont Dam Mega-Tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens Mega-Tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a mega-wave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega-tsunami, the largest in Earth's history. The first waves almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot-high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half-inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moore tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long.
At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known Mega-Tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world. especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas Fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas Fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. This is not some hypothetical situation or fairy tale. The Vesuvius supervolcano that erased the city of Pompeii may wake up again and destroy many other towns built near the mountain. And to understand what consequences humanity would face if it wakens this time, it's smart to know what the eruption did 2,000 years ago with the ancient city. So, Pompeii was a thriving city in the Roman Empire, located just 5 miles from Vesuvius on the west coast of Italy. It was a resort where the noblest and richest people rested. They walked along cozy streets, lived in beautiful villas, and had fun beside fountains. The soil in this region was fertile since the ground around the volcano had a lot of useful elements. Olives and grapes from Pompeii were sold throughout the empire. About 12,000 people lived in Pompeii by the time of the eruption. It seems not so much compared to modern standards, but it was considered a big city in those days. The catastrophe began unexpectedly in 79 CE. At first, everyone felt the ground tremble. Birds flew away from the volcano as far as possible. There was tension in the air because of the impending catastrophe. The volcano started to release thick smoke, soot, and ash. There was so much of it that soon it obscured the sky over the city with a heavy gray cloud. Vesuvius spat out gases, rocks, and dirt. Hot ash polluted the air and made it difficult for people to breathe. Locals couldn't see inside this gray haze. And then it started raining heavily. The water mixed with ash and soot and fell on Pompeii. Roofs of houses broke under the heavy weight of mud. Streets, fountains, alleys, and squares were hidden under millions of tons of soot. The next day, the destruction continued with renewed force. There was an explosion of hot gas and crushed rock at the top of the mountain. A devastating blast wave at a speed of 100 miles per hour dispersed in all directions and vaporized all the trees in its path. When the wave reached Pompeii, it turned the city into ruins. On the second day, the eruption stopped. By this time, the great town had been lying under a thick blanket of ash. By the way, this type of eruption is called an explosive one. But when lava flows out of a volcano and causes a fire, this is a quiet eruption. The last time Vesuvius erupted was in 1944, but even today, it's still one of the most dangerous volcanoes in the world. But nobody's afraid of it. 3 million people live around the mountain, about 20 miles from the crater. If the volcano wakes up, it could be one of the most enormous cataclysms in the modern world. Pompeii was destroyed almost 2,000 years ago. Since then, science and technology have advanced a lot. We're planning to colonize Mars someday. We've created a metaverse, but so far, we're still powerless before the forces of nature. An erupting supervolcano can destroy nature around it and cause technogenic catastrophes in big cities. The phone lines would be overloaded and people wouldn't be able to call their loved ones or the rescue services. There would be big traffic jams on the roads. Panic would spread throughout the streets. Fires would start because of falling hot soot. All flights would be canceled, and locals would have to hide in airports, supermarkets, and the subway. A large gray cloud would obscure the sun and make the air hot. The only thing that can help us in such a situation is a preliminary warning about the upcoming eruption and good preparation. So if the disaster starts while walking on the streets, you should take shelter in a car or building. It's better to buy a dust mask in advance that allows you to breathe freely. If there's no mask, cover your nose and mouth with any cloth. If you stay at home, close all doors and windows so volcanic ash can't get into your apartment or home. These incandescent particles can easily set fire to a carpet or curtains. Put wet towels under the door sills. If you need to go outside for some reason, wear a suit covering your body completely. Don't forget about the protection for your eyes. Put on special glasses that have a dust-proof function, and remember about the mask. If you have a house, you need to disconnect the downpipes from the gutters to avoid clogging the drains. If your house has a rainwater collection system, you need to disconnect the pipes from the tank. Rain with ashes is a hot, dense mess that can easily break the water supply system. Fill the tub and sink to have water for washing and cleaning in case the central water supply is turned off. Set the lowest temperature on the fridge and freezer. Your food will be stored much longer if electricity is shut down in the city. Go to a room without windows above ground level and wait for a message from authorities on the radio or TV. Keep the receiver close to you so you don't miss anything important. The device must have a full charge, a strong body, and a powerful antenna. Here's an excellent option for survival in the ash apocalypse. The eruption is intensifying, and you hear on the radio about the evacuation. At this point, you need to calm down and follow the instructions from rescuers. Collect a bag at home with food, water, and medical supplies. Your emergency kit should include flares, maps, a first aid kit, sleeping bags, flashlights, a fire extinguisher, a portable phone charger, car tools, and a few charged batteries. You should always have a filled gasoline canister if you live near an active volcano. Going to the gas station is not a good idea during the evacuation. You can get into a long traffic jam and spend too much time in it. If you don't have a car, ask your friends for help or pay someone for a ride. It's possible the city administration would organize buses for evacuation. You would find out about it through the radio. In any case, before leaving the house, don't forget to turn off the gas and electrical devices and shut off the valve with the water supply to prevent your home from a gas leak or flooding. So, you're driving a car. The authorities must announce the plans for evacuation. Don't go off the route because some roads can be blocked. Perhaps they will say the eruption is over and you can return home. Maybe the eruption will be so strong that it will destroy the city. Anyway, if you're prepared, you'll have fewer things to worry about. Modern seismic sensors monitor the fluctuations of tectonic plates and the volcano's activity, so the eruption won't be a surprise. Pompeii is far from the only city destroyed by the eruption. In 1785, a similar disaster occurred in the Japanese town of Aogoshima. It was located right in the crater of an active volcano, and one day it woke up. It was sunny weather, and no one suspected a disaster was coming. At some point, the birds rose in the air and flew away. Then the ground began to shake. A heavy, low sound came from the depths of the island, and thick streams of smoke and ash erupted from the volcano. The volcano threw dirt and big red-hot stones into the sky. It looked like a meteor shower. People evacuated, and the mountain continued to erupt for several weeks. When the ashes settled, the volcano fell asleep again, and people began to return to their city. Despite the risk of a new eruption, they continue to live and work there today. Since then, more than 200 years have passed, and the volcano never woke up. Meteorological and seismological services monitor the situation and seismic activity. After all the horrors and devastation that a volcanic eruption leads to, harmony in nature eventually comes. Decades and centuries later, volcanic ash, rich in helpful food elements, settles on the soil and makes it fertile. Then life will rise from the ashes like a phoenix.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse. All food chains would be broken. And only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who who will have the opportunity to study the marine animal's response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only two confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, it lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore. Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, It had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling. The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored. Sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock, it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super-hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earth shake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Well, pack your bags and hurry down to Antarctica, because gold is literally raining from the sky there. $6,000 per day. Well, not exactly from the sky, more like from the eruptions of this massive fiery volcano. The towering beast of a mountain is called Erebus. It looms over the icy, lifeless expanse of Antarctica on Ross Island. It shares the spot with 3 neighbors, Mount Terror, Mount Bird, and Mount Terra Nova. Although Erebus is certainly dominating the place, it's about 12,500 feet tall, like 8 Empire State Buildings. Now, even though it's far smaller than Mount Everest, it's still the southernmost active volcano in the world. And even though it stands in the middle of nowhere, Erebus is far from lifeless. It has a terrible temper, actually. Erebus constantly breathes and roars, throwing out gases and chunks of molten rock in crazy tantrums called strombolian eruptions. And among them, it spews out tiny, delicate specks of shimmering gold. And it's not a couple here and there. This money fountain works every day, spewing out nearly a quarter pound of gold per day. Like we mentioned, it's worth over $6,000. It also sums up to a crazy 64 pounds of gold per year, over $2 million. But before you treasure hunters rush there, we have to tell you that these are more like particles of gold. They're often less than 60 micrometers in size and are scattered around, impossible to collect. And when we say scattered around, we mean it. Some of those particles have been found as far as 620 miles away from the volcano, carried in the middle of nowhere by Antarctic winds. Now, Erebus isn't a super friendly place to hang out next to. Its eruptions are wild and unpredictable. So, most of what scientists know about Erebus comes from satellites, which monitor its activity from the safety of space. For scientists, this place is also a gold mine. Erebus is the only volcano that can do this stuff. They figured out that this happens when the magma, Superhot semi-molten rock beneath the Earth's surface rises to the volcanoes. Magma brings some liquid gold with it. The moment it meets the chilly Antarctic air, the gold crystallizes into little pieces, and voila! $2 million per year. Erebus is such a weird and rare volcano. Its fiery heart has been burning for over 1 million years. Over these million years, it's been building layer by layer. Its basis is a super ancient lava, and the upper layers are youngsters. And throughout many years, it's been very active, with a glowing lava lake bubbling at its center. This lava lake is exactly what it sounds, a pool of constantly shifting, burning molten rock. This site is incredibly rare because there are only several lakes like that in the entire world. And this isn't just a pool of rock, it's a window into the volcano's soul. In Erebus, it's made of phonolite. Now, phonolite is a very cool rock. Its name comes from the Greek words for sound and stone. Because, guess what? It's a rock that produces a ringing sound when you strike it. There are only a couple of volcanoes that give it to us. But it's not the only volcano that can flex its weirdness. Oldoyenyo Lengai, a volcano from the East African Rift in northern Tanzania, is even more mysterious. It spews what's called nitrocarbonatite lava. Most volcanoes erupt glowing red-hot rivers of molten rock. But this one erupts dark lava. It flows super fast, like water, creating these thin, fast-moving rivers. So all this makes it look almost like black mud or oil. What's even wilder is that as soon as it hits the air, it starts reacting super fast and turns white within hours. It's like magic, with black lava turning into something that looks like white dust or snow. Not even mentioning that it even glows faintly at night. And it's not that hot either. Well, it's still pretty hot, from about 900 to 1,000 degrees Fahrenheit. But usually, lava temperature can vary from 1,300 to 2,200 degrees Fahrenheit. So it's cold by volcanic standards. That's because this lava is rich in some strange soda and salt-like, incredibly rare materials: nerorite and gregarite. Nerorite is usually colorless and shiny, looking like small clear crystals or plates. Gregarite is often a bit cloudy. These guys are a geochemical mystery. Deep inside this place, there are two pools of magma. The rare minerals are probably born when carbon-rich parts of magma get separated from the rest, forming these two pools. And while they're fascinating, and we can get tons of them from this volcano, they're also completely useless. They're so rare and fragile that they're impossible to use in anything, even jewelry. Still, even astronomers find this curious. If there are planets out there that are rich in carbon instead of oxygen, like Earth, these minerals could be quite popular there. This volcano also releases a lot of gas, and I mean a lot. It's spewing out carbon dioxide at a speed of about 176 pounds per 1 second. Just think about it, about 5 tons of carbon dioxide per minute. Every minute, that's like several cars worth of gas being pumped out into our atmosphere. Luckily, our planet is used to this volcano, so it's not that dangerous to us. Meanwhile, in the central Andes, far from human reach, Listaria is having the time of its life. This is also one of the most extraordinary and remote volcanoes in the world. This one is even taller than Erebus, rising to almost 18,700 feet. It's surrounded by a barren, otherworldly landscape. There are literally no humans within 90 miles around it, except for some volcanologists. Listaria is absolutely wild, constantly breathing out hot gases and steam. The air seems almost alive there, shimmering with plumes of vapor escaping from cracks in the ground. These vents, called fumaroles, are more than just hot steam. They're basically chemical labs. They spit out tons of various gases, all of which react with the air and rock around, and what's left behind is something otherworldly. It's like someone spilled a painter's palette, bright yellows, fiery oranges, and rusty reds. But the wildest part are molten sulfur rivers, streams of bright yellow liquid bubbling and flowing down the sides of a volcano. Some of it is still burning, darkening, like some sort of weird s'mores. All that because the sulfur is getting heated to its melting point by the intense heat below and turns into a thick, glowing liquid. Then it starts flowing, cooling, and hardening. You can't tell if you should be fascinated or disgusted by this sight. And if that's not enough to make you feel like you're on another planet, the place itself is just as extreme and crazy. Listaria is perched high on the Altiplano, at the edge of the Atacama Desert, one of the driest places on Earth. Pretty much no rain, and temperatures can plummet to minus 11 degrees Fahrenheit. At least some volcanic ash enriches the soil, so there are some hardy plants here and there. The weirdest part is a salt pan nicknamed Lake of Sulphur. It's fed by those sulfur rivers. It shimmers with minerals all along its shores. This lake used to be way higher in ancient times, but now it's just a shadow of its former self. Thousands of years ago, it witnessed a catastrophe of unimaginable scale. The southeastern side of the volcano, a huge part of it, crumbled and fell in an instant. The ground just gave way, and an avalanche of volcanic rock and ash thundered down the slopes. The landslide raced at terrifying speeds, faster than the fiercest storm, tearing apart everything in its path. It tumbled for 5 miles. When the dust settled, all that was left was a massive scar about half a mile wide. We learn this story from the debris around the place. Ash, pumice, and lapilli all are the shattered remnants of the volcano itself, lying now at its base. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a Mega-Tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.